My name is Jason Munn. I'm a student at River Ridge High School in the Engineering Academy. I am partnered with Stefan Hadju, who I could not with in the making of this video because we only work together at school during the day. The problem that we found is with go-kart and mini bike clutches. The options are really only two: a centrifugal clutch, which uses friction, and a drum to transfer your power, or a so-called torque converter, though it is really a belt-driven CVT. Centrifugal clutches are very inexpensive. They're about $50 a piece, but they have their drawbacks where they are very susceptible to dirt, mud, and water, and they generate a lot of heat. The problem with them is that they have three stages really in any clutch, where you have your idling stage, where the engine is spinning free from the output, the engagement stage, where the input is catching up to speed or is spinning faster than the output but is still transferring power, and then you have your lockout stage, or a fully engaged stage, where the input and the output are locked together. A centrifugal clutch is not designed to stay in the engaging stage. After a very short time, it gets very hot. If you prolong your engagement period, you will very quickly wear out the clutch. The problem with the clutch is that trying to get high low-end torque and high top-end speed. We have a lot of torque as you're accelerating, so you can go like in a mini bike where you can go through an off-road trail smoothly with a lot of torque and no effort, and then go fast as you're going down the really long trails that are not that challenging or safe to where you can go fast. The CVT, although it is called a torque converter, it is not a true torque converter. The CVT uses a belt and two pulleys that expand and contract, and it changes the gear ratio from the engine to the output. The problem with these are also susceptible to water, oil, etc., and they have an RPM limit. A popular thing is to take these engines and rev them over the standard RPM, which they are built, you build them to that, you add performance parts so they do not fail, and it is safe to do that. The CVT is limited on their RPM. It can jam up in the engaged state if you over rev them. So my partner and I set out to find a solution. We looked at current clutching problems, looked at the science behind them, and the best option we found was inspired by a automatic transmission. If you ignore the gearbox and the planetary gear sets of an automatic transmission, you have the torque converter, which uses fluid coupling to transfer power from the input to the output without any friction or direct contact. So we designed a proof of concept using fluid coupling for small engines. On the smaller part of the orange drum would be a sprocket, which would be the output. If we go over to the back, this plate is removable to show the turbine and the impeller. Here is the impeller in the closed state. This is always connected to the crankshaft. And here is the turbine that is connected to the outer shell, which is outputted, which is the output shaft. The entire clutch is filled with a fluid, like transmission fluid or something of the nature that lubricates but is thick to where it can transfer power through fluid dynamics. As the engine idles, the turbine stays in this state, but as the engine accelerates, as you accelerate the engine, the centrifugal force pulls these fins out. And the faster you throttle the engine, the more it pulls them out. So at their max extended point, they are able to transfer a lot of power, in theory, through to the fins. And then as the engine slows back down, a spring-loaded ring collar will pull all of these back down simultaneously, back to their original state, completely disengaging the engine from the output. This is a rough proof of concept. Future designs would hopefully be a lockout clutch, to where when the engine and the output are close in RPM, it will lock them out so you have total power delivery when you're at top speed. Another intended design feature will be serviceability, where you can take it apart, place parts that need to be, and put it back together and spend very little money. This is designed to hopefully be competitive with the current clutching solutions, but be a longer lasting solution to where you don't have to keep buying new parts for it. You just service it. Just like an automatic transmission. You just service a transmission. If you take care of it, it lasts a long time, the life of the vehicle. The impact it would have on the community would be pretty cool, because it would allow builders and hobbyists who build go-karts and mini bikes and any other vehicle that you can imagine. It's amazing what the community can do. Gives them a lot more flexibility on their drivetrains and allows them to generate more power and more torque out of the same engine. I'm working with my instructor, Mr. Samuel McCamus, who is the engineering teacher at River Ridge High School. He is helping us with design concepts. This is not the final prototype design. We need to change it so it is more able to be made, because right now it has very difficult parts to make. We need to change it so it can be manufactured. Southern Manufacturing Technologies would like to talk to our group about producing a prototype so we can test this concept and see if this will work. I'm very excited with the opportunities that I've been given throughout my life to lead me to this point. And it is awesome to me to see how something I can draw up in a sketchbook and then make in this CAD program, and then it be in my hands, and then it working. And looking at it and thinking, I built that. And even if it doesn't work, you learn and you see what's wrong and you fix it. And then you find something else that's wrong and you fix it again until there's nothing else wrong, and then it works. And so I'm just excited to see what the rest of my life will bring me.